Hi guys, hope you all are doing well. We are continuing our Unit 4 review, still in Unit 4.2, and today we are talking about triangle similarity. So as a recap, similar triangles are triangles that have the same shape but a different size. Same shape meaning they are to scale. So for example, if we have a triangle that has one side that is 1 unit, one side that is 2, one side that is 3, we could have another triangle that is 2, 4, and 6, meaning it's the same shape. This one is just expanded by a scale factor of 2. Similarly, we could have one like this that's 0.5, 1, and 1.5 that is reduced by a scale factor of 1/2. I don't know why my pen stopped working there. But that is what similar triangles are. We have 3 types of similar, or like 3 theorems rather, that we can use to prove that triangles are similar. The first is angle-angle similarity. I'm just giving my pen a chance to rechart here. Angle-angle similarity is when you have 2 sets of corresponding angles that are congruent. And that's enough information to prove that the triangles are similar. So you don't actually need to prove that all 3 angles are congruent. 2 is enough. So looking at question number 1, we know that angle A is 75 degrees and angle D is 75 degrees. Well, that's one set of congruent angles. We have B is 74, and we don't know what its corresponding angle E is, but we could find it because we know that all 3 of these angles add up to 180 degrees. When you know 2 of them, you can find the third, right? So 180 minus 75 minus 31 leaves you with 74 degrees. So this angle is then congruent to this angle. You could have done the same thing and found C and you would have gotten 31, right? Because it all is going to add up to 180. It does not matter. Either way, we can say, yes, these triangles are similar. And then writing a similarity statement means we have to match up the angles. So A, B, C is going to be similar to D, E, F because A and D match up, B and E match up, and C and F match up. Right, so the similarity statement needs to be in the right order. So that's angle-angle. Next, we have side-side-side similarity. This is exactly as it sounds. Right, we have 3 sets of proportional sides. This one involves matching up your sides. So you want your smallest with your smallest. So 3 is your smallest here and 6 is your smallest here. I'm doing this little squiggle to mark them because if you do a tick like this, that implies congruence and that's not what we're trying to do, right? So 3 is to 6 as 5 is to 10 as, did I do that right? Yeah, that's the largest. As 4 is to 8. All right, so we have the smallest, which is 3 and 6. The largest, which is 5 and 10. And then the medium, I already did that color, 4 and 8. All right, it doesn't matter which order you go in. You could have done like 5 and 10 first, and then 4 and 8, and then 3 and 6. It doesn't matter. And it also doesn't matter if you put 3 in the numerator and the denominator, as long as you're consistent, right? So 3, 5, and 4, because they belong to the same triangle, they all need to be in the same place, either in the numerator or in the denominator. So next we want to reduce these fractions, simplify them, and see if we get the same thing. So 3 over 6 is 1/2, and 5 over 10 is 1/2, and 4 over 8 is also 1/2. So yes, these all have the same scale factor, meaning the triangles are similar. Essentially what happened here is you just multiplied the first triangle by 2 to get the second triangle. So yes, and then matching them up, we have P, Q, R is to S, T, U. All right. Lastly, we have side angle side similarity. This is when you have two sets of corresponding sides that are proportional, and the included angle, meaning the angle that is being touched by both of those sides, is congruent. So I'm actually going to do number 6 because this is one of those like triangle and a triangle ones that I know some of you struggled with. So if you need like a visual, right, this is the small triangle, and then this is the large triangle. So it's not like a triangle and then like a quadrilateral. All right, so you can kind of draw them out separately if that helps. Small, big. So for the small one, this side is 12. This side is 15. We don't know the other side, but that's not relevant, right? For the bigger triangle, this is 21. This is 25. Now, they didn't have to give you like all of this information, right? They could have given you like part of it, and you would have to kind of like mess around with the triangle and get the pieces that you're missing, but this one did give us everything. And this is like the reflexive property of angles, right? It's the same angle that exists for both triangles, so we know that it's congruent to itself. Then we want to see if 15, the bigger side, is to 25, as 12 is to 21, the smaller side. So go ahead, this one is, not as easily reduced. Plug that into your calculator and see if you get the same thing. So 15 over 25 is 0.6, and 12 over 21 is 0.57, etc., which is not equal. It's close, but it's not the same thing. So the answer to this question is no, these triangles are not similar. All right, so I want you to finish this page, 2, 4, and 5. And also, I don't want you to do these. I want you to do page 37. All right. Oh, where did it go? Okay, so you're finishing page 34 and page 37, and I will post the answers to these tomorrow. I'm going to try a new thing just for fun. Miss Peterson actually suggested this to me, and I'm going to include a code word in the lectures. And if you need help and you're reaching out to me about this particular thing, similar triangles, you need to use the code word, and the code word that I'm making up right now is gator. So if you want help on similar triangles, make sure you tell me gator so that I know you watched this, and I would be happy to help you if you give me a call and let me know. All right, I will talk to you all soon. I hope you have a wonderful day, and good luck with this. Oh, make sure you do the IXL.